optical fiber modes and configuration. Objective: fiber types and configuration, modes and rays. Fiber modes and configuration. Fiber types. Optical fiber is a dielectric waveguide that operates at the optical frequency. The transmission properties are dictated by fiber structural characteristics. The structural characteristics declares the information carrying capacity. The propagation of light along the waveguide can be described in terms of a set of guided electromagnetic waves called modes of the waveguide. Fiber types. These modes are referred to as bounded or trapped modes of the waveguides. Each guided mode is a pattern of electric and magnetic field repeated at their wavelength. Optical fiber. In this, it consists of structural of optical fiber. It consists of core having a refractive index of N1, gladding refractive index of N2. N1 is always greater than N2. And basic structure of an optical fiber. The structure of optical fiber consists of three: core, cladding, and coating or wafer. The basic structure of an optical fiber is shown in figure. The core is a cylindrical rod of a dielectric material. Light propagates mainly along the core of the fiber. The core is generally made up of glass. The core is described as a radius of A and the refractive index of N1. The core is surrounded by a layer of material called cladding. Even though the light will propagate along the fiber core, without the layer of cladding material, the cladding does not perform same necessary function. Cladding layer is made up of dielectric material with a refractive index N2. N1 is greater than N2. The cladding is generally made of glass or plastic. The cladding performs the following function: reduces loss of light from the core into the surrounding air, reduces the scattering losses, protects the fiber from observing surface contaminants, adds mechanical strength. For extra protection, the cladding is enclosed in an additional layer called buffer. The material used for buffer is plastic. The buffer is elastic in nature and prevents absorptions. The buffer also prevents the optical fiber for scattering losses caused by microburns. Low and medium loss fibers, plastic core and plastic cladding, and in the plastic less expensive, flexible and lighter. And the glass material core material is glass and cladding are of glass or plastic. Optical fiber based on material. Optical fibers are made up of material like silica or plastic. Basic optical fiber material will be the following property: efficient type for the light waves, low scattering losses, absorption, attenuation and dispersion of the optical energy must be very low. Based on the material used for fabrication, they are classified into two types: glass fibers and plastic fibers. Glass fibers consist of SiO2, core and cladding. Optical fiber based on refractive index profile, it can be classified into step index fiber, uniform refractive index throughout the core, and the refractive index changes in a step fashion from the center of the core to the cladding. Refractive graded index fiber core Ri is made to vary as a function of radial distance from the center of the fiber. So these are the fiber types depending upon the type of optical fiber. Monomode step index, monomode step index fiber, and monomode graded index fiber. Based on the both step index and graded index fibers are classified based on the number of modes that propagate through the optical fiber. There are single mode fibers and multi-mode fibers. So single mode and multi-mode fibers. In multi-mode fibers, many modes apply propagate through the fiber. Single mode fiber only one modes. Multi-mode fibers that propagate through the fiber travel different distance based on the entry angles. The SM fiber uses laser to launch light in a somewhat concentrated fashion. Multi-mode fiber uses LED to launch the optical signal. So the SM fiber is capable of high bandwidth and greater cable run distance than multi-mode fiber. Transmission light along the optical fiber can be described by two theories, ray theory and or geometrical optics. Ray theory is used to approximate light acceptance and the guiding properties of the optical fiber. Mode theory or wave representation approach. The light is described as electromagnetic. The mode theory describes the behavior of light within a fiber. The mode theory is useful in describing the optical fiber properties of absorption, attenuation and dispersion. Based on the ray theory, the modes consist of two types, meridian ray and the skew ray. Meridian ray can be classified as bound or unbounded rays. Bounded rays remains in the core and propagate along the axis of the fiber. Bounded rays propagate through the fiber by total internal refraction. Unbounded rays are refracted out of the core. Figure shows the path taken by the bound and unbounded rays. The core of the refractive index is a index of 1, M1. The gliding of segments however, imperfection of the core gliding intervals will cause part of the rays to be refracted out of the core into the cladding. The light rays refracted into the cladding will eventually escape from the fiber. In general, the rays follow the law of reflection and refraction.